Hello guys, welcome to another tutorial series. What we'll be talking about today is a countdown timer using OLED display and a Rotary encoder, which is basically this. This is the OLED. This is Arduino UNO. This is LED. The reason for this LED majorly is supposed to be red is to indicate when the time runs out. So you can see on the screen the time is on 00. That's why the light is on. So right now, if I decide to reset this timer, which is on 10 seconds right now, so you can see the LED light went off. Now it's counting down. 3 seconds, 2 seconds, 1. The moment it goes down, the LED comes up indicating that the time is up. This LED can properly, I think red should work better since it's a stoppage sequence, but just for the sake of this tutorial I used green. Doesn't matter, but in your own case you can use red. This project itself can be used in a lot of things, like chess playing, a timer system, any system that requires a timer. If you need to program anything to work with a specific time, this system can help you do that, in the sense that if you're to program this, let's adjust this. You can see on the screen I'm taking it to, let's try and put it on 1 minute. So as you can see, right now the timer is running down from a minute down. The moment it comes down from that 1 minute to 0, this light is going to come on. That is to say, you can program this timer with the help of this Rotary encoder to give you any specific time you want. Once the system goes down, the time will stop. It can also be used in a sports event when time is needed. There are a lot of use cases for this project, but basically this is just to explain how countdown timer works. In the next tutorial I'm going to show you how you can modify this into a stopwatch which can either count upward or count downward. But basically, as you can see, let me zoom out a bit. The system has zeroed. That's why this LED light came up. So basically this is just how the timer works. So next I'm going to be showing you a step-by-step connection of this process, every single wire where they need to go into. And this description of this video, we're going to get the circuit diagram for you to be able to do this. And also by watching this video you'll be able to do the connection step by step, because I'm going to connect each of this module phase by phase, wire by wire. So you just need to follow along, pause along as the video plays in order for you to follow properly. So let's do the connection right away. So guys, welcome to the connection of this circuit. As you earlier watched the video, this is the circuit breakdown. So what we're going to be doing here is a step-by-step connection of every of the components you see on the screen. As you already know, we have all these components you can see at the background of this title as part of this project. So what we'll be doing is do a run through of the entire connection. So basically what we are trying to do right now, we are still on the topic OLED countdown timer using Arduino. These are Google technologies. So let's dive into it right away. So right now we're going to talk about the requirement for this project, because in order for us to do the connection we have to know what we need for this project. So let's dive into that. First is Arduino UNO. The major component here is the microcontroller board Arduino UNO. So we are using R4. This is R3 on the screen, but Even if you have Rotary, it doesn't matter. Any of the board you have, be it Arduino UNO, be it Nano, be it R3, be it Mega, you will still achieve the same result. The only difference is the position of the pins. As long as you're able to locate them, just as we have analog and digital pins on the Arduino UNO, we have the same on the Arduino Mega and as well the Arduino Nano. So basically, whichever board you have, you are good to go. Just locate the pins. That's all you need. So the next thing is I2C OLED display. Basically, this OLED display is just a 4-pin OLED display, talking about the VCC, the ground, the SCL, serial clock, then the serial data. So the next one here is a Rotary encoder. Rotary encoder is more like your regular potentiometer, but in this case, there is really no limit to how much you can rotate this. The rotation continue continuously, unlike your potentiometer that goes from a point and end at another point, depending on the configuration. But in the case of Rotary encoder, you have a push button on it. You also have the rotation knob, which continuously go forward or backward as you need it. So this is a Rotary encoder with the pins clearly stated here, and we'll do that connection in a moment. So we'll also be needing an LED, a red one precisely, though in this project I use a green one. It doesn't matter which LED you use. The major reason for this LED is just to glow, letting whoever is using this project to know that the time has come down to 0. This LED will only glow when the timer hits 0. So that's the use of this LED in this project. So basically, we have a resistor. For a better glow of this resistor, you don't have to use a 10K or 1K. Just use 200 ohms resistor. That will work better because the higher the resistance, the dimmer the LED is going to glow. But the lower the resistance, the brighter the LED. So the last but not the least on the list is jumper wires, because without jumper wires we won't be able to connect these devices together. So we'll be needing a jumper wire in order for us to connect it. So basically we are using a male to male jumper wire because everything is from the Arduino UNO to a breadboard where majority of the components are mounted. So right now let's dive into the connection proper. So the first thing we're going to connect here is our LCD display. As you can see on the screen, this is our ground. The ground of the LCD display is connected to the ground of the Arduino UNO. So after that, we connect the VCC. The VCC is connected to plus 3 plus 3 volts, because this LED mostly, though the power rating for it is from 3.3 volt to 5 volt, but from experience, most times 5 volt damages this LED depending on the manufacturer with time. So it is safer. It's not like when you use 5 volt it won't work, but in order for you not to damage this LED, this OLED display very fast, it's advisable to use 3.3 volts to power the OLED display. So after that, we're going to connect the serial clock, which is the SCL. Now the SCL of this OLED display is connected to the LCL of the Arduino UNO, while the SDA is connected to the SDA of the Arduino UNO. As you can see here, these two pins here are for SCL and SDA. So on this screen right now, this is the connection for the OLED display to the Arduino. What we have left is these two components, the Rotary encoder and the OLED display, as in the LED, in order for us to know when the timer hits 0 on this OLED. So basically we're going to do this connection first before this one. So right now we're going to do the ground connection of this LED. So as you can see, this is the negative of the LED. The bigger chunk inside the LED glass is the negative, while the smaller part of it is the positive. One thing I've noticed is it doesn't really matter where you put this resistor. As far as this resistor is there, the LED is still going to work fine. Even if you place it at the positive terminal, it doesn't matter. The resistance will still be there. So this is our common ground from the Arduino UNO. The ground of this LED connected via the resistor is done already. So what we need to do right now is the signal coming to this LED. So let's connect that. Now this LED is connected to pin 5 of the digital pin of the Arduino UNO. That is what sends the signal to this LED once the timer hits 0. So right now we've done a connection for both the OLED display and the LED. What is remaining right now is our Rotary encoder, which has 5 pins. As you can see here, we have our ground, our VCC, our SW, our DT, and our CLK. So right now let's just do the connection. If you want to know what this all stands for, just try and do a pinart search on Google on this Rotary encoder, and each of them will be explained to you. So let's start with the ground. This is the ground connected already. Like I told you, we have a common ground from the Arduino, so it's using that common ground. And the VCC as well, we are using a common VCC for every device here. So we are using the same VCC that went to this as the OLED display for this Rotary encoder. The next one is going to be the SW pin, which is this one. Then the SW pin is connected to pin 4 or the digital pin of the Arduino, while the DT pin is connected to pin 3, while the CLK clock pin is connected to D2 on the Arduino UNO. Excuse me. So what we have here right now is the complete circuit connection of the OLED display system. This is a countdown timer using Arduino. The basic connection is what you have on the screen. So right now this is very clear. This image is in HD. I make sure it's in HD so you can always zoom as much as you want. This circuit diagram is going to be in the description of this video. The code of this circuit is also going to be in the description of this video. All you need to do is just click on get the circuit and the code, do the connection, upload your code and run your test yourself. And yeah, everything works out well. You should have the same result I had on the video you watched before this connection. So right now what we need to do is to do the upload on our IDE, Arduino IDE. So right now let's do that. So guys, IDE is open. This is Arduino IDE. So right now let me just open the sketch we're going to be using for our project. I'll just open OLED countdown timer. Code is already prepared. All you need to do is just select your board and then upload. Alright, this is the code. So what you need to do right now is just click on Tools, select your Arduino board, Arduino UNO, then ports, select the port. In your case, you have to locate your Arduino port which is being selected by your Arduino UNO. One thing, how to know which of the ports your UNO is using on this on your own computer. You have to try to probably detach you have to detach your UNO, then reconnect it back. Then you notice one of the ports will disappear and reappear. That should be your UNO port. Another way is for you to use your device manager. You go through device manager. Once it is opened on your computer, let's hold on. Once it is open, you click on ports. Then here you will see which of the ports your Arduino UNO is using. So once you detected it here, you can go to close this, go to your IDE, go to ports, select which of the ports your system needs. Once that is done, this is the upload button. You do your upload. I believe if you're watching this video, uploading a basic sketch to Arduino UNO will not be an issue for you. So just do this, then test your project. All things being equal, if your wiring is correct, the system should kickstart without any issue. So thank you for watching. If you like this video, please like and share. Subscribe to this channel. Also, don't forget to hit the notification button, that whenever a video is uploaded, you'll be the first to be notified, so you don't miss anything. Thank you for watching, and see you in the next video.